Now to solve this question, we first start by writing KCL at node A in here. So first I'm gonna start by assigning the currents. I'm gonna assign, here we have I1, here we have I2, and I'm going to assign I3 in here, and it doesn't really matter which direction you assign the current to as long as you stick with your notation. So here we have I2 going into node A, we have I1 going out and I3 going out. So KCL at node A would be I2 equals I1 plus, this is I1 plus I3. And after that, I'm going to get rid of the current terms by using Ohm's law. So let's look at I2. I2 flows through R1. So how can we get rid of I2? Using Ohm's law, I equals V divided by R. So I2 goes this way, right? It goes from here to here. So what is the voltage on this side of R1? It's going to be V in 1 minus the voltage at this point. What is the voltage at this point? It's going to be V out. So V in minus V out divided by R1. And then same thing for I1. So I1 goes this way and it flows through R2. So it's going to be V out divided by R2. And for I3, I3 flows through I3 and it flows this way. So it's going to be the voltage here minus the voltage in here. Now the voltage in here is V out minus the voltage at this point. Now the voltage at this point is going to be minus V in 2. Remember, this is the negative terminal of the supply. So it's going to be minus V in 2 divided by R3. Now from this point on, it only becomes a matter of manipulating the terms and isolating them. So what we're going to do is that we're going to multiply this whole equation by R1, R2, and R3. So if I multiply this by R1, R2, and R3, R1 goes away. We have R2 and R3. So we have R2, R3, and then I'm going to spread the term. So R2, R3 multiplied by Vn minus R2, R3, V out equals R1, R3, V out plus R1, R2. This is R1, R2 times VO plus R1, R2 times V in 2. Now remember that we are looking for V out equals K times V in 1 minus K2 times V in 2. So we want to take the terms with VO on the left and the other terms to the right. So here I have V out, here we have V out. So I'm going to say R1, R3. I'm actually going to say V out on this side. So I'm going to take this term to the right. So we would have V out and R1, R3 plus R2, R3 equals, here we have V in, this is actually V in 1, I should have specified that in here, this is V in 1. So here we have a V in 1, there's no other terms for V in 1, so I'm going to write R2, R3, V in 1, and we have, oh, we actually forgot one term in here. We have a term in here it's R1 R2 times VO, so I'm just gonna add it here. So here we have plus R1 R2, okay, and then we have R2 R3 V in 1 and R1 R2 V in 2. And then I'm gonna divide by this whole term right here. So it's R1 R3 R2 R3 R1 R2. I'm just gonna call this R, this whole thing I'm gonna call it R just for simplicity. So we have VO equals R2 R3 divided by big R V in 1 plus R1 R2 divided by R times V in 2. Let me double check on everything. So we took R1 R3 and we have R1 R2 and R2 R3, and we have this. We only forgot to change the sign on this one because we took R1 R2 Vn2 to the left, so this is just going to be minus in here, so this is minus, and here we have it. So this is going to be K1, this is K1 Vn1, and this is K2 Vn2. So it will all depend on R1 and R2. So we see we have the denominator is common to both of them. They both have R. So we will only compare R2, R3, and R1, R2. And if you compare them, you will see that K1 is bigger. So Vn1 will have the bigger effect on the output voltage.